I found some problems. I look at your solutions. Yeah. I just look at the, how did you solve these problems? So I want to talk about a few questions. All right, selected questions. I get the solution file almost ready. Yeah. After this class, I will do last round revising. So then I will post it. Yeah. So for some relatively easy questions, that I do not spend time. So you just study the solution file. For relatively hard questions, I talk about some, common errors. Yeah. All right. Yeah. So let me start from the first one. The first question. Yeah. I look at your answers, your methods used. Yeah. So I found only one of the 6 did it correct. The remaining 5 half correct, not completely correct. Yeah. So the problem is the problem is very common for those 5 students. First 6 element, then last 6 element. 2 part. Yeah. The error is in the first half. The first one, from the given questions, they are ordered. They are ordered, so those 5 students, they didn't count any comparisons. They didn't count this part. So there are a certain number of comparisons for first half. They only do the second half. The second half, they did correct. But they missed the first half. Why is that? The reason is they're based on this condition. This condition. So here I guess, based on my experience, I try to understand their thinking. So these 5 students. Since the first 6 elements have been sorted, that means we do not need to do anything, right? So then they start insertion from X7. So that's not correct. The question, so here what I give you is the input. Input has this property, okay? Input has this property. But I remember this point I mentioned before. That is computers do not have eyes. Computer cannot see it, right? Even if the first 6 elements are ordered, but computers do not know it. Computers still need to run the insertion sort on it. Okay? Yeah. You need to enter the whole array as the input, and your code need to run your for loop, taking the insertion steps one by one. Yeah. For each iteration, just do it as usual, just like the first 6 elements are not ordered. So in that way, we know that corresponds to the best case, right? For the first 6 elements, that corresponds to the best case. Yeah. But I need 5 comparisons. So each first element, no comparison. Second one, you add 1. Next one, you add 1. Each one, you just add 1 more. So you add 5 comparisons. You can do faster, but you have to do it, right? So for the first half, you have to do it. You cannot just jump to element 7, number 7, so then you start insertion. So that logic is not right. The logic, you need to run your whole insertion algorithm from beginning to end. Because nobody wants to do the checking for the first 6 elements ordered, but in our algorithm, because the checking expense is very expensive, not worth it. Not worth it. So we cannot afford checking step. So we just run our standard insertion sort on it. No checking. That means the first, this part, this work, you cannot skip. That's the common question. That's 5 out of 6 has this problem. Yeah. So the next time when you see the similar situation, so I gave you information about the input. Remember in our first assignment, homework assignment number 1, we did a few questions. In my instructions, I said, those properties are hidden. Hidden fact. That means you cannot do anything special on the hidden fact because you do not know. Only after you complete processing, then you can see, oh, this input has this kind of special property. But when you run your code, you do not know. Your data has some special property. So that same understanding we need to use here. It is a hidden fact. The first half ordered hidden fact. So you cannot, change your code or do any change based on this property. So that's a, very important understanding problem. That's the understanding problem. All right. Next, so then I talk about, because in our final exam, what should I do? How do I modify questions? Because basically I modify our old questions for the final. For example, for this question, I can modify in this way. Because in the final, I cannot give you the same question, right? Or just change the data size number. So that's too easy. So I want to make the modification non-trivial modification. So my idea is non-trivial modification. Yeah. So you need to do something special based on your experience. You already have a lot of experience, but you need to modify your thinking. Yeah. So you need to do some special treatment on your data. Yeah. For example, here, the condition first, yeah, because this condition is very simple. So I may like to give you, yeah, here I'll give you an example. How do I modify this question? Example. All right. So the data has this property. So what property? I'll tell you. Given the length of its longest ordered chain. How about that? Ordered chain. Yeah. For example, let me draw a simple diagram. Right. So we have x1, x2, all right. For the general input, this is the general input, all right? Yeah. You know, definitely unordered. Yeah. But in my given condition, I do not give you the, you know, which sequence. Yeah. I only say there exists certain ordered subarray, you know, inside. So inside the input, there is some ordered subarray, but the longest, because the length of ordered array related to the number of comparisons, right? Yeah. Longest. Yeah. You know, here, for example, the 6 elements. So I may say the length of longest ordered chain is 6, for example, like this. That means the location. So location is not the first 6 elements. The location could be anywhere, right? Yeah, you know, spread, yeah, in different locations. But we can identify those 6 elements. If we take them out, we get a ordered subarray. Yeah. So that information, think about that. So if you need to do anything special, subarray. Okay? I give you length. Yeah. I'll give you length equals some number. Yeah. Because I ask you the maximum number of comparisons. Yeah. So for different locations, your number of comparisons could be different. Yeah. Think about that. Yeah. Think about that question. Okay? Yeah. So here I'll give you an example. How do I modify our existing questions? How do I do non-trivial modification? Okay? Yeah. Yeah. So get ready for things like that. All right. Yeah. So that's the first question. The second question, yeah. So I found some common error. Yeah. So the second question I want to point out, one commonly used way many students do in their homework assignments. We know we have two types of questions, right? Yeah. Answer type and solution type. Now, answer type, if your answer is correct, so your solution details does not matter, but the solution, the details, that part, it matters. The detailed work, it matters. Yeah. So here, for this question, yeah, so many students use, because there is two ways to get the answer. The first, estimation. Second, working part. Yeah, there is a working, specific estimate. That means by formula. Yeah. So here, many students, because we have that lower bound formula, right? Equals 5. Okay, yeah. So that's the, first way. Yeah. Many students use this way. The answer is correct. Yeah, 5. Yeah. This answer is correct. Yeah. All right. The working part. Yeah. So you have the specific work. Working. So you need to do comparisons. Comparisons. You need to tell me how to do it. It's different. Yeah. But for answer type questions, this way, if your answer is correct, then you get full credit. Yeah. Because I do not look at your solution details. Yeah. So your solution details sometimes could be problematic. Yeah. It's not perfect. Yeah. Yeah. But you happen to get a correct answer, I still give you full credit because that's the answer. Answer type questions. But for solution type, the working details matter. So I need to look at your working details. Matter. So even if your answer is correct, but your solution details incorrect, I only give you, 1 point. So 3 points for the details, 1 point for the answer. So that's the difference. So for this one, actually this way, estimate, this way, not good for solution. Why? Why not good for solution? Because we do not know if we can make it. You may not be able to do it, right? So your estimate, this is your estimate. What do you get is a lower bound. What you get is a lower bound. So that means nobody can do better than this number. But another question, can anyone do it using this many comparisons? It's unknown. Only when you work on it step by step, give all of your comparisons, then follow the logic, then people know if you can solve this problem in this many comparisons. That's different. All right? Yeah. So for this question, yeah, most of you, yeah, based on my impression, about 4 out of 6 using the estimate method to do it. Yeah, answer correct. So I still give you a full credit. Yeah. Yeah. But you need to know, yeah, because this way, yeah, for this question, you got it correct. Yeah. But this way may not be reliable, right? Yeah. Because if I give you a different question, so you calculate the lower bound, but if nobody can do it, then I need to question, how can you make it? Right? So you claim, so this is the answer, but how can you make it? Yeah. So only we know people can make it. Yeah. Only we know people can make it. Then we count it. So your answer is correct. If nobody can make it, so then we cannot say your answer is correct. So that's the logic. So that's the risk when you use this method. Yeah. But one thing, yeah, because if you cannot use other method to solve this problem, then this method, at least you can get a partial credit. So that's the, so when you apply this method, you need to know all these things behind it. Yeah. But, so what I mean is, if the problem is not too hard, so you try to do the comparison work. You try to do the comparison work. If it's too hard, yeah, so I understand. So you try your best. But this question, actually not too hard. Not too hard. The correct way to do it is like this. Yeah, actually these two questions, similar. And for question number 2, related to our existing question, I did it in class. Sort 5-element array in 7 comparisons. We did it in class. Yeah. I give you all the details. Similarly, number 3, I can talk about together. Not sort. Yeah. So number 3 is, yeah, find the median of 5. In 6 comparisons. We did it in class. Based on your solution details, after I look at your solution details, I noticed one thing. Most of you are not quite familiar with the details of these 2 examples. Not quite familiar. Yeah. Because many of you did it from scratch. I saw some of the students, yeah, so put some work to earn partial credit, did it from scratch. If you go back to look at your notes, you can find the solution on our notes. You know, my handwriting. Remember some slides. I drew the diagrams, you know, round one, round two, you know. Yeah. So to answer these two questions well, I expect you should be familiar with those two examples, the solution details of those two examples. That's very important. These two questions, extremely important for this class. You know, yeah. So in your knowledge part, these two examples very important. After taking this class, you should be very familiar with the solutions of these two questions. Yeah. All right. So here, I do not want to repeat that solution, but I want to recall the basic ideas of these two solutions. The reason is we need to talk about the given condition. So, how much useful information can we get from the given condition? I want to explain this question. Okay, all right, yeah. So for the question number 2, yeah, I think I need some space. Anyway, let me split my available space 2 halves. This half, second half. Okay, all right. Number 2 goes here. Number 3 here. All right. And for these two questions, the round 1, the first part, similar. Yeah. That's the tournament method. Yeah. So for the first round, we run the tournament method. Okay, yeah, first round. Tournament method, but when we run the tournament method, we have freedom to choose how to run it, right? Yeah. So people are familiar with the tournament method, but still we have some small freedom to choose. So here, our freedom is, in the first question number 2, the first pair between x1, x2. The second pair between x4, x5. Winner x2, winner x5. Yeah. First comparison, second comparison. Here we know these two comparisons given, right? Yeah. That means we can save. We can save 2 comparisons from the given condition. So you complete it, all right? So after that, let's say 5 is the winner. So we complete the round 1. Then round 2, we draw the diagram. We have longest ordered chain, x5, x2, x1, x4. Yeah. So this is the longest ordered chain, right? Yeah. All right. Then there is a x3 element. So then we do the binary insertion, right? Yeah. Binary insertion, 2 more comparisons. Okay? 2 comparison. Yeah. After that, then we insert the last one. That's our old solution. Yeah. Here, what I want to say is, after, if in your mind you know the detailed solution part, then you connect to the given condition, because this given condition you can save 2 comparisons. The total number of comparison you need is 7, but 2 of the 7 you can use the given condition to cover. So you don't need to do those 2 comparisons because you already have them. So 7 minus 2 equals 5. So that's the way you get 5. You can make it happen. Not this estimate way. Estimate way, although you get 5, but still there is some uncertainty there, right? Uncertainty. You don't know if the given condition can help you make it happen or not. You don't know. It's unknown. Because sometimes the given condition could be some garbage condition, right? You cannot use it to do anything useful. It could happen, the given condition. That could happen. Yeah. But here, the given condition can be completely used. Yeah. Yeah. Because that's part of the solution. Part of the solution. So that's why you can use full 2 comparisons. Sometimes the given condition. So here there is another. Remember I mentioned the equivalence idea. Yeah? So the given condition equivalent to 2 comparisons. Yeah? Some students use that equivalence argument. Equivalent to 2 comparisons. All right, given condition. Yeah, but many students use that equivalence approach. Actually, I feel they abuse the equivalence approach. They abuse it. What I mean is they use it incorrectly or partially correct, not completely correct. Because, for example, if the given condition is x1 less than x2 less than x3, how can you use the equivalence condition to translate this condition? Yeah. Some students still use 2. Some students use 3, yeah, because you need a 3 comparison to solve 3 elements. Some students use 3. Some students use 2 because the best case is 2, right? Yeah, the best case is 2. Worst case is 3. So sometimes students use given condition equivalent to 3, sometimes equivalent to 2. Yeah, both incorrect. Yeah. Actually, if you talk about equivalence, it's less than 3, greater than 2, somewhere between. Yeah. You get information more than, a little more than 2 comparisons, but less than 3 comparisons. So in this situation, you should not use the equivalence approach. Yeah. All right, so that's the number 2. Number 3, you need to bring back that solution, then you do some modification. Yeah. All right, so we select 5 elements, and when we select 5 elements, we need to contain these 4 known elements. Yeah. Partially known, right? Yeah. 3, 39, 40. Then, because your first round tournament, right? The first round tournament. So when you run this tournament, you have freedom to choose how to pair your elements. So x39, x40, x2, x40, and you know, these two comparisons, you do not need to do it, given. Given, you can save two comparisons. Then, the first round, okay, all right. So let's say x40. Then the second round, so you have diagram for the x2, x1, x39. But second round, the way we handle the data is quite different from previous example. Previous example, we do binary insertion into the longest ordered chain, right? Yeah, but here, we do not do binary insertion. We do elimination. Elimination. Yeah. On what? Not a median, okay? Yeah. Because greater than 3 elements, not a median. So it could be eliminated. Then the remaining elements, then we find 3 remaining second largest. And we know how to find second largest. So that's the, you know, the solution for this example. Now, yeah, here you do not need to repeat, but if you are familiar with all these steps, you know the first round, you only need information from the first round because the given condition can be completely used in the first round to save you 2 comparisons. The whole solution, you know, 6 comparison, and you save 2 from these 6 comparisons. That's why you get 4 comparisons. Yeah. Some students give me the correct answer 4, yeah, but I don't know. How did they find it? Yeah. So I hope they use this way, correct way. Sometimes, so they may use the wrong way, you know, just to do some very rough work, but the answer is correct. So for this type of questions, I give you full credit if I see your answer is correct. So most of the time, yeah, sometimes, so I look at the work is, you know, too bad, so probably I may take 1 point off. Yeah. So if the work is not that bad, okay, not completely wrong, so partially correct, partially wrong, I give you full credit. Yeah. All right. Yeah. So that's these questions. All right. Next. Yeah. Yeah. So number 4. Yeah, number 4. Number 4. The problem. I saw some problem in number 4. Yeah. So I want to mention, yeah, because in the final, I will give you a similar question. So I want to make you aware of it. What is the right way to answer this kind of questions? Yeah. The correct answer, 25. All right. But some students give me larger number. Yeah. So I saw at least 2 students give me numbers greater than 25, you know. Yeah. So then I look at their work. I noticed they use the worst case formula. Worst case. Yeah. Here, because the input we have here, descending order, it happens to correspond to the best case. But some students use the worst case formula. Yeah. So then your answer is much larger than this number. Yeah. So that's one. Another problem, another common error here I want to mention. Yeah, I want to, emphasize common error here. Yeah. But these students, for this question, they got the correct answer. Yeah, I will give them full credit, but I still want to point it out, the potential problem. Because in the final, if you still do solve similar questions in this way, it's very likely your answer will be incorrect. So what's that? Yeah. So they solve by a recurrence relation. Yeah. Why this method is problematic? Why is that? Because when you apply recurrence relation, for this question, it's correct. Yeah, because it corresponds to the best case. It's correct. So when you use recurrence relation, it works for best case and worst case. Yeah. Worst case. Yeah. If the input does not correspond to best case or worst case. Yeah. So in the final, so let me tell you what I'm going to do in the final. Yeah, final. Yeah. The input is neither the best case nor the worst case. Something between, because I need to check your understanding of the details of the merge sort. I want to use this question to check your understanding. So you need to do the specific merge details step by step for input, for the general input, not the best case, not the worst case. Because no recursive formula can cover it, because it's too complicated to describe it by any recursive formula. So you have to do the merge detail. So in my solution file, I give you the detail. Yeah. So you can study so here, let me show you my solution file. Here, number 4. All right. So the input, here descending order, so that's the input. Yeah. But in the final, I will change this order. I will give you certain order that is not ascending order, not descending order. Somewhere between ascending, descending, mixed. Okay? Yeah. Part of it ascending, part of descending, like that. Mixed. All right? Yeah. But I do not want to make it too complicated. Yeah. But you know, I want to control a little bit. Yeah, because if I make it too complicated, then it will take too much time from your 2-hour testing time. Yeah. So but I want to check, you know, if you apply recurrence relation, you won't get correct answer because the input is different. Not best case, not the worst case. So here I show you what's the right way. You need to do divide and conquer, right? The first time divide and conquer 1, that, you know, divide step number 1, you split in the middle. Yeah. Second round, divide step, second round. Then third round, okay, third round, all right? Yeah. After that, you know, the last round split in 2. Then I just, you know, combine. So we do our first comparison, second comparison, you know. Yeah. So that's, after that, when you do merge, so based on the given data, you can arrange the order. You can count the number of comparisons. Here, I use this notation. Look at inside parentheses. I store 2 numbers because later we have 2 questions. We need to use these 2 numbers. Here, the first number means number of comparisons. The second number tells us the size of merged data. 4 elements, total 4 elements, 2 comparisons. So the comparisons, yeah, because how do you know you need this many comparisons? By the given order. Given order. Because we know how to run the merge operation, right? Yeah. So you know how to run the merge operation. Yeah. So you connect to the merge operation to give you the number of comparisons you need for each merge step. Yeah. Each merge step, based on the given order, you can count the number of comparisons in this merge step. Yeah. All right. So then, you know, every merge step, you know, subtotal, then you add up all the subtotals to get a total. So that's the right way to do it for a general input. So here what I mean, a general input. So I want to see if you really understand the details of this, you know, basic merge sort. Yeah. So 1 question is good enough for that part. Yeah. So you need to, you know, study this part. And number 5, they are similar, you know, similar. Just the data size is different. Yeah. So you just study this solution details. Yeah. After you understand the logic, so then in the final, when I give you different input order, yeah, not as easy as this one. This is the easiest case. Yeah. So I can make it slightly harder. Yeah. Slightly harder. Yeah. All right. So then you need to do some special treatment. So when you count the number of comparisons, some places the counting is different. Not in best case formula and not in worst case formula. Somewhere between. So that's the question you can expect in this final. Hope you do not need too much time to work on this question. Yeah. All right, so that's these two questions. All right. Then next, let me see. Right, so number 6 we skip, because relatively easy. So you just study the solution file. Oh, next, number 7 and number 8. I want to combine them, and so in the final, so you will have 2 questions similar to these 2, but I need to make some non-trivial modification in the final. So I want to talk about the right way to solve these 2 questions, correct way. So from your solution work, I noticed some problem. First, for the number 7, first question, I saw 2 different answers, 39 and 51. 39 and 51. 39 is the correct answer, but 51 is wrong. 51 is incorrect, because here we need to apply the best case formula, 51. So those students use the worst case formula. All right. So that's one. So then there is another way, because here there are 3 ordered arrays. When you do the merge, you have several ways to do the merge, right? So here, sizes of ordered arrays. A, B, and C. All right. So when you do the merge, you have different ways. The first way, you merge A, B, then you get A plus B, right? Right. The size A plus B. Then you merge C and A plus B, right? So that's what. So there is another way, merge, because when you change the order, your result could be different, right? C, B, C. So you get B plus C. Then you merge A and B plus C, right? Then you have third way, merge A and C, right? A and C. Oh, sorry. A and C. So you get A plus C, and then you merge B, A plus C. So you cover all the possible cases here. 3 possible cases. Then you pick the best one, the one with the minimum number of comparisons for your answer. All right. Similarly, for second question, you also do the same thing. The only difference is the formula is different. Worst case, you use the worst case formula when you do the merge. The best case, you use the best case formula when you do the merge. That's the only difference. All right. But here's the problem. So this method is not efficient. So this biggest problem. So although it's correct, but the problem is not efficient. Especially for our final, because our time is very limited. We need to solve 10 questions in 2 hours. 10 questions in 2 hours. So we need to use a very efficient method to solve these 2 problems. All right. So in the final exam, so these 2 similar questions, I will change the ordered 5 from 3 to 5. 5 ordered arrays. So in that case, you have to use the correct, efficient. You have to use some efficient method. Efficient method. Yeah. Otherwise, too much work, because when you have 5 ordered arrays, you have too many different combinations. Large number of cases. Which one is the best you can get? Hard to see, right? Yeah. Sometimes hard to see it. Yeah. All right. So now I give you the right way to answer these 2 questions together. All right. The correct way, efficient way. Efficient method here. Apply the greedy algorithm. Remember, I talk about greedy algorithm. In module 1, remember? So I talk about this topic in our module 1, part B. Evaluate polynomials. That topic, I talk about greedy algorithm. Greedy strategy. You can recall a little bit. Yeah. All right. So here, we need to apply certain greedy strategies. All right. But for these 2 questions, best case, worst case, they have different greedy strategies. Although we apply, greedy algorithms, but the definition of the greedy strategy is different for these 2 questions. All right. So let me talk about the greedy strategy. All right. Worst case and best case strategy. Okay. All right. Greedy strategies. Definition. All right. For best case, okay, strategy number 1. For worst case, strategy number 2. Let me give you here. All right. Based on these 2 strategies, you know how to, Yeah, because when you do the merge, every time you need to select two of the ordered arrays from the list, right? Yeah. For the first question, you have a list. This is the list. 16, 23, list the sizes. 35 from the sizes of the list of the sizes. 19, 27, 45. That's your list. Yeah. But in the final, when I give you 5 ordered arrays, so your list contains 5 size numbers. 5. All right. So our greedy strategies are applied on the size numbers, list of size numbers. All right. Best case. Yeah. The strategy is merge the shortest and the longest ordered arrays. In the list. Yeah. So when you select 2 subarrays to merge, suppose you order those 5 numbers in ascending order, okay? So you pick the first one in the list and the last one in the list, you do the merge. After the merge, because you get a new ordered array, then you need to insert that size number into the list of sizes to update your list. So that's the strategy number 1. Strategy number 2, merge the 2 shortest ordered arrays in the list. Because in this way, you only need to do it once. You do not need to, run many different cases. So you apply these 2 greedy strategies. So you only need to work, one round. You can get a correct answer. Yeah. All right. Yeah. So let me give you a simple example. Yeah. Yeah. So in order to make you understand this part a little better. Yeah. So let me just use a simple example. Okay. Suppose we have the list. So here I select 5 random numbers to show you the basic process. Like 5, 9, 13, 21, all right, yeah. In ascending order, right? Yeah. Ascending order. Yeah. Now, I want to work on the best case. Okay? Yeah. So we need to apply the first greedy strategy. All right. Step 1, we merge. Shortest 5, longest 32. Yeah. Then the number of comparison, yeah, because the minimum of the 2, right? So 5 is the number of comparison. Then Vertical bar, I want to separate the total size. Yeah, because size number is useful. Okay? 32 plus 5, 37. 37 is the size number. All right. So because we take away 5, take away 32, so we cross out. But we need to insert 37, right? After the merge, we have a new array with size 37. Yeah. So 4 numbers, if you update. So if you update your list, 4 numbers, 37. Okay, that's step. Step 2, same strategy. Merge, shortest 9, longest 37. So you get the minimum of the 2 numbers, that's 9. Sum of the 2 numbers, 46. Okay, all right. So cross out, gone, but you need to insert 46. All right, yeah. Step 3, merge, shortest in the list, 13. Longest, 46. 13, sum of the 2 numbers, 59. All right. So you have the remaining 21 and 59, right? Yeah. Remaining 2 size numbers. So the last merge, yeah, you need to have 4 merges. Last step, 21 and 59. Minimum 21. Sum 780, right? Yeah. All right. Then, to calculate the total, you only use the 4 numbers from the first column. Okay? So total. We calculate total. 5 plus 9 plus 13 plus 21. That's the best case strategy. So worst case, so you know, different. Yeah. So I do not need to do the worst case example. So after you get the idea, so you can apply greedy algorithms on these 2 questions easily. Yeah. Then you do not need a lot of time. Yeah. I think 5 minutes should be enough. Okay. 5 minutes for each of the 2 questions should be enough. Yeah. So that's the something special you need to, you know, you need to expect in the final exam. All right? Yeah. So let's look at the next question. Yeah, greedy. Oh, yeah, the next, I plan to do last 3 questions, the challenging last 3 questions. Yeah. So let's take a break. Yeah. So let us, just a minute. Oh, yeah, yeah, because yeah. Yeah, these questions you just look at the solution. Yeah. So these 3 questions I do not have much to explain. Just study my solution file. Yeah. Now, so we have 3 challenging questions left. Let us take a break. So when you come back at 7, yeah. So then we complete the remaining 3 questions. All right?